Hello everyone. Today we're going to talk about monorepos with PNPM. Okay, we're gonna explain how you can turn a single monorepo or a single repository or multiple repositories and combine them into a single what's called monorepo. And for that, we're gonna use a tool called PNPM Workspaces. The tool is actually PNPM. Workspaces is a feature that PNPM offers. Sweet. Today it's going to be a little bit presentation and a little bit interactive. We're going to create a monorepo from scratch to see exactly what are the benefits from it and how you can implement it yourselves. But I think it would be great if we start by just defining exactly what's a monorepo. Like, what do we get from it, right? So essentially, I already kind of said it, but usually when you're working on different projects, or maybe you have one big project but has like separate concerns, and I'm going to give you a very simple example. Imagine a SaaS application where you have the front end, and maybe you also have the back end, and maybe you also have, I don't know, some set of internal tools or different APIs, so different backends, or maybe you have also a marketing side, which is a separate project too, etc. So all these things that are kind of related between them, it's very common to have them separate in different in different repos. Sorry, not monorepos. In different repositories. You have the repository for the front end. You have the repository for the marketing side. You have the repository for the server. You have some repository for an internal tool that maybe you need to use for any reason. And in some cases, it's a good thing to have concerns separate. But in other places, maybe having a monorepo can help you a lot improve many things. Monorepo essentially will take all these different repositories and dump them all together in a single repository and use the tool like PNPM Workspace to properly manage it. Because it's not only about just having everything under a folder and that's it. We actually need some kind of system that help us properly manage this, right? So what are the benefits of this, aside from having all concerns together in a single repository? And I guess that the first one is that you have more visibility, right? Because if we go back to the example that I said, where you have, let's just imagine a very simple SaaS application where you have the front end and the server, so you have two repositories. A monorepo would help you combine them, and you'll be able to understand everything that is going on in the SaaS application by just looking at a single repository, right? You don't have to be switching between different repositories, checking, okay, on the front end, this is happening. Now I need to go to the back end and let me check what's happening. Is it matching? Is it not matching, right? So it gives you more visibility of all the different parts of the system. Let's call it a system, which can help a lot also onboard new people, learn how things work, etc. Right? Second benefit is that you can do code sharing, right? Imagine, for example, that between the front end and the server, which are two separate repositories, maybe you are running some similar logic between them. Or maybe you have something that it's kind of duplicated. We can imagine, for example, TypeScript definitions, right? Where the front end is expecting to consume the server, and the server has its own type definitions for everything from the database. But the front end also needs those type definitions, right? Because when you're fetching from the server, you want to know exactly what you're getting from it. Am I getting an array of strings? Am I getting a number? Am I getting an object? What am I getting, right? So maybe you're having duplicated things between the front end and the server. Or maybe you have some utilities, right? Maybe there are a few functions that are exactly the same function. You have it on the front end and you have it on the server, or any other repository that's also involved in there. And you're essentially duplicating things, right? The moment that we move everything under a single repository with the monorepo, we can extract those shared code bits, those shared blocks of logic, and we can just put them in a separate package. And that package can be consumed by everyone. So it helps a lot reusing things and making sure that something that it's being used on one place matches what's being used on another place, right? Which brings me to the part of standardization. when you have different repositories, maybe in those repositories you have different settings, maybe you have different conventions when writing the code, or when checking, when linting, or when, I don't know, approaching any kind of solution, any kind of problem. When you put everything on the repo, you can standardize all of that. You can share the same treaty logic. You can share the same ESLint logic. You can share the same type definitions. You can share the same naming conventions. You can just make sure that everything it's following the same standards, because everything is under a single place, which also is good, right? And the last one, and actually it's one of the most powerful ones, it's that it's easier to manage and collaborate when you have a monorepo with where multiple parties are involved. Okay, imagine that, for example, a server and the front end, that basic example from an ASS application. Imagine that you want to make a change. So maybe that change will involve requiring to update the server and the front end. Maybe you're changing how something is being processed on the server. And also, because you're making that update, you also have to update the front end to adapt to that change, right? So you're updating in multiple places. When you have it in separate repos, you have to kind of coordinate between everything, right? You have to update one repo, check that the changes from that repo are correct. You have to, if you're using GitHub issues and you're opening pull requests, you have everything scattered between different repositories. You have an issue in one repo, an issue in another repo. Then maybe you need to open an issue for a bug, and that bug it's not only specific to one repo, but it kind of affects multiple repos. So you have to duplicate that issue in multiple places. Kind of organizing things and making sure that you know exactly what's happening in the entire system at all times. It's also a big benefit of a monorepo. So I think that I've talked enough already. I think that we can start actually doing something, right? Let's. My plan today is to create a basic monorepo, and we're gonna follow an example of what if we have multiple Webflow sites, because we are Webflow developers. So let's imagine that we have multiple Webflow sites. Each of the site, it's kind of unique, so it has different things, right? So it has maybe some special logic for some pages in each site, but also all the sites, maybe they share something in common. Maybe you have some, I don't know, some UI kit that you want to share across all of them. Maybe you have some utility functions that you want to share across all of them. Maybe you have, I don't know, anything that you could think of. So maybe some data, for example. So we're going to do that. We're going to imagine that we have a bunch of Webflow sites. I'm just going to make up everything. So don't trust the info in there, because it's going to be very bad examples. But I think that it should still help you understand how things work. So let's get right into it. I already have VS Code open. And with VS Code, what we want to do is create a new repository. Okay, first we'll create a standard repository, and then we'll tweak that repository to convert it into a monorepo. Okay, the tool that I'm going to use for that, I already mentioned at the beginning, but it's going to be PNPM. Okay, PNPM, and it's an alternative to NPM. It's a package manager. And the good thing is that it has workspaces functionalities that are built in, and they work very well. It's really powerful. It's very, very performant, and it just works out of the box. It's amazing. Okay. So the first thing that you want to do, if you're coding with me, is make sure that you have installed PNPM. And the way that you can do it is you open the terminal in the directory where you want to create that repo or whatever. And let's just do PNPM install -global, because we want PNPM to be global in my machine. And then we'll just say PNPM. Okay. In my case, it's going to be fine, because actually no, with PNPM, with NPM might update it. Okay. Yep. I already have it in my machine. And now what we can do is create a new repo. And for that, we can start by doing PNPM create, like this. Actually, I'm just going to use a dot, because I'm already in the directory where I want the repo to be created. But if you wanted that repo to be created on a new folder, then I would type here the name of the folder. In my case, I'm just going to use a dot. like this. And obviously something is going wrong. It's actually PM init, I think. Yeah, sorry, it was PM init, not PM create. Okay, PM init is going to create a package.json. Okay, and essentially with the package.json, we already have a repo. We already have something. That repo, we can then move it to GitHub or GitLab, wherever you want. Okay, but with this, we can already start, right? So usually we can already start coding stuff. We can already do something like this, console log, hey, for example, and then I could run this code, and I would, if it saves this, hold on a second. Today my computer is slow. Yeah, well, the code is working, right? But what we want to do now is split things up and create different packages. Okay, in a monorepo, the way that we separate things, it's by using packages. Okay, every single package is going to be a new piece in the system. It can be the front end, it can be the back end, it can be a site, it can be another site, it can be a utilities package, it can be a type definitions package, it can be anything that we want. Okay, in our case, what I'm going to do is I'm going to create a new folder, and I will call it packages, not packagey, but packages. And inside these packages, I will create those different packages. Let's create a site that is called bugs. Okay, and another site that it's going to be called bug fixes. Okay, cool. So we have these two sites. One site is going to be for, let's just come up with something. It's going to be users reporting bugs. And another site is going to be a site where we collect solutions for those bugs. Okay, it's a very, very inconvenient system because usually you would want to have everything together. But okay, that works. That works. Okay, so what we want to do is, first of all, we want to initialize a package for each one of these different folders. Okay, so I'm using the terminal. I'm going to cd into packages and into bug fixes for now. And I'm going to do the same. I'm going to do pm init. Okay, like this. And I will just create a package.json also in bug fixes. And I will cd back into the bugs folder. And I will do the same. Okay, so pm init. Okay, cool. And let me go back to the root of the repo. And let's clear this up. Cool. So we have three different packages right now. Okay, one package is for the monorepo. It's what we call the root package. Okay, one package is going to be for the bug fixes site, and one package is going to be for the bugs site, right? So now what we can do is already start coding, but we have to tell pm that this is a monorepo. Okay, and the way that we do it is by just creating a single file that it's going to be called, I think it's pm workspace YAML, but let me just confirm because I'm pm workspace.yaml. Okay, and in here we just need to list exactly what are the packages that we want to have for the monorepo. In this case, I'm going to write packages colon and then tab, and in here I will just say packages that / asterisk. Okay, essentially with this what we're saying is, hey, everything that falls into the folder packages, okay, so packages, anything inside, I want you to treat it as a package from the monorepo. Okay, but we could make exceptions, or we could have something else. Maybe I also want to have some global folder. I don't know why, but and in here you also want to have different packages. You can also add it here. So you could also say global folder, or maybe an asterisk, or maybe you can even say specific names. Maybe you want to initialize, I don't know, global utilities like this. It's up to you. You can even negate things. Like, for example, imagine that we have an additional folder here that is called private, but this folder, you don't want it to be packaged in the monorepo. You can also negate things. You can do like this. Actually, it goes inside packages private, like this. So essentially with the bang, with the exclamation mark, you can negate thing, just saying, hey, don't include this one. Package private goes away from here. Okay, but for now, just packages is fine. So we'll delete this, and we are good to go. We're good to start. Let's start. By the way, today I think I'm going to be using just JavaScript, because otherwise I have to set up everything like ESBuild, compile everything. And today I want to focus on actually using monorepos. So I'm not going to use TypeScript. I'm going to use JavaScript. But if we have enough time, maybe we can talk about how you can take the developer starter template from Finsweet and convert it into a monorepo, because it's probably something that maybe you're looking into doing. Okay, I think that we'll have enough time today to do that. Cool. So let's start by just doing an index.js. Okay, I'm gonna do it. Oops, not a new folder. I'm gonna do it in both places. Okay. And let's imagine that in bugs, we have some logic for the bugs, okay? And in the bug fixes, we want to address the fixes from the bugs, right? So imagine that we have, I'm just gonna make up something, but we have all the bugs as an array, okay? And this array, it's gonna be something like ID 1, title, my computer stop, I don't know, busted into flames, whatever, okay? So we're gonna have, let's say, a couple bugs in here, and this is gonna be title, any bug ideas. I'm really bad at coming up with names. Okay, I'm loving already GitHub Copilot. My computer busted into flames again. Okay, cool. So we have these two bugs, right? And imagine that in bug fixes, which is a separate site, we want to address those bugs, okay? So we could, for example, try to come up with the fixes, right? And maybe you would like to do something like, I don't know, ID 1 and the bug, the 1, etc. Okay, but maybe we want to reference them, right? Maybe we want to say, hey, I want to reference exactly these bugs that I have defined in this package. So we can talk about how to share logic between packages. This is the next step that I want you to explain. Okay, so how can we share logic between packages? The first thing that we need to do is make sure that each package has a unique name. Okay, in my case, this is going to be, okay, bug fixes, that's fine. And bugs. Okay, cool. We already have unique names. And this also has a unique name. Cool. It's stream monorepo. So what we can do is just install the packages the same way that you would install a package from npm. Okay, so if I cd into my package, it's going to be bug fixes, for example, I can just do pnpm add. And the same way I would install a different package, I can install the bugs package. Okay, and what pnpm will do is it will look into the workspace, and it's going to notice, hey, there's actually a package in the workspace that's called bugs. So instead of fetching that package from npm, it fetches it from the workspace. You can see how pnpm already defined it to be from the workspace. And now it means that anything that is exported from this package can be used in this package. Okay, I know that these bugs and bug fixes doesn't seem very helpful at all, okay, but it will make sense once we start seeing all the things that we can do with it. Okay, but for now, let's just try to share the logic between this. Obviously, I need to export from the bugs package, right? Because right now I just have these constant defined, but I really am not exporting it. I'm not sharing it outside of the package. We need to explicitly do that. So the first thing that we can do is set this as an export. Okay, and then we'll go into our package.json. And actually, that's already fine, because we want to make sure that the main entry file is an index.js, okay? Or if you wanted to define multiple exports, like, actually, hold on. Let's just first talk about main.js, main index.js, and then I'll expand a little bit more this. Okay, cool. So now in bug fixes, we have a package called bugs. which means that I can already just do this, import from bugs. And the good thing is that PNPM just treats the experience. It helps us have the same experience as when we install a package from npm. If I check this, we have the bugs already available for us. Even it makes the type definitions, everything. It's completely good to go. I can already start using it. Imagine that I want to generate some fixes. Now I have access to the bugs. So maybe I just want to do something like bugs.map. And for each bug title, I can say return ID. It's going to be the same ID. And maybe the fix will be a fix for the title, like this. Cool. So now we can check how the fixes are going to be based on the bugs that we had defined in a different package. So let's just run this. Oh, hold on. Okay, cool. This is good to have this bug in here. See how I tried to run this, but it's warning me you're trying to use ESM imports, but you have not defined the type module in package.json. This happens because anytime that we use import export syntax, which is the ESM, what's called ES modules, we have to explicitly define that in package.json. So what we can do is go to package.json, and we'll create another field in here that it will be type. And it's going to be module in this case. Okay. And I'll do this for both bug fixes, also for bugs. And I don't know if it actually makes any difference, but I will also add it to the root package. Okay. So now that we have that, let's do it again. Let's run. And by the way, I'm running the index.js file by saying node space and the file that I want to run. Essentially, I'm just saying, hey, I want you to take this index.js file and use Node.js to run that file. Okay. So if we do this, look at it. We have the fixes. Fix for my computer busted into flames, and fix for my computer busted into flames again. Okay. We have essentially shared logic between two packages. It seems like it isn't much, but it's really a lot. I mean, it's really helpful. The bigger the system is, the more you're trying to scale a project. Being able to split things and just share the logic between them, it's very, very powerful. Imagine that, for example, we create another package with some utilities, right? And in those utilities, we want to, create some function, some reusable function. You can share that between the server and the front end, for example, if you have a SaaS application with a monorepo. So very powerful. Okay, cool. So we've talked about how to create a monorepo, very simple. How to share logic between packages. Well, how to create packages in the monorepo. How to share logic or resources, let's call it, for between packages. Let's talk about using commands, running commands. Okay, so what we can do, for example, is imagine that in each of the packages, we have a script that it just, I don't know, failed. Or not build because we're not building anything. Let's just say start. Okay. And for start, we just want to do node index.js. Okay. So essentially, when I run pnpm start, I want it to essentially just do the same that I did before. Node index.js, run the logic. Okay. And also, maybe I want to do the same for the box package. I also want to do start like that. Okay. And are we doing something here? No, we're not. Okay. What could we do in bugs? Could we? I don't know. Let's just console log the bugs. Okay. And actually, by doing this, you will see a cool thing. Cool. So if I go back to the box package, I can also do pnpm start, and it will do the same. It will do node index.js, and in this case, it will console log the bugs. Okay. Now that I'm doing this, actually, let's go back to bug fixes. And this is just something if you're curious, but if I run now pm start again, look what happened. When I run pm start now in bug fixes, look what just happened. It not only console logged the fixes, it also console logged the bugs. Okay, why is that happening? We are importing the bugs in here, right? And on the same file where we import the bugs, we actually running some logic, which means that anytime that we access that file, in this case for exporting the bugs, this logic is going to run too. So you got to be careful with this. So imagine that you have something that's really just specific for the server. Like imagine initializing the server. You don't want to have that at the same place where you're exporting things and sharing it between packages, because the moment that a package accesses that file to grab something from it, the entire file is going to execute. So if you have some logic like executing a console log in here, like this, that console log is going to run, or that server is going to initialize, or whatever logic you have in there. So be careful about that. Maybe what we could do is we could just, but for now, let's just do it. Hold on, because I really want to have that console log in here. Let's do, for example, maybe with this we can see exactly different ways of exporting things. Let's do, for example, init or start.js. And from start, I'm going to import. So I'm just going to say console log bugs. Cool, like this. And now I'm going to remove it from the index.js. And in the package.json, instead of doing node index.js, I'm going to do node start.js. Okay, because with this, now we are fixing the issue. Okay, whenever we're running bugs, let me go back to the bugs folder. If we run pm start, it's going to run just, whoops. None. Okay, yeah, I needed to specify the file name. So now it's just gonna console log this, but when exporting things from index.js, now if we go to the bug fixes and we do pm start, now it's just gonna console log the fixes and not the bugs too, okay? Because the bugs, it's in a separate file where the console log it's not happening, okay? I don't know if this makes sense, please don't give me a thumbs up, but it's important to know exactly how things are connected to avoid having, experiencing unwanted behaviors. So imagine now we have these two scripts. We have the start script on the bug fixes package, and we have the start script also in the bugs package, right? But imagine that I actually want to run everything at the same time, right? Imagine that those sites they have some kind of server that I need to spin up, or maybe, I don't know, I need to build those sites, right? So I want to run the command for both at the same time, or imagine that I have 10 packages. Maybe I want to use that command all at the same time, okay? So instead of having to cd every single time into the package name, what we can do is in the root folder, we also can define a script. And in this case, maybe we want to call it start all. I don't know. This name is completely up to you, but maybe I'll just do start, okay? And in here, what we can do is say pm start, but we'll say that it's recursive, like this. So with this R in here, what we're saying is, hey, recursively run this command in here. So I want you to run pm start in all the packages recursively, okay? So if we do this, now we are in the root package, we are in the stream monorepo directory. We can do just pm start, and now it's gonna run first. Okay, cool, let me show you what happened. It's gonna run first the start file in the bugs package, and then the start file in the bug fixes package. So it just went recursively through all the packages to run this, okay? But this doesn't stop here. We actually have more controls. Imagine that for any reason, I just want to run a specific package. Maybe we want to start just the bugs package, right? We can also do pm start. And what we can do is pass a filter. So instead of going recursively one by one and running everything, we just say, hey, filter, and I want you to filter the package that it's called bugs, like this. So pm filter, and whatever matches this, in this case, it's a bug, it's the bug's name, run the start command. And if I do this, now I do pm start bugs, it's only going to run the bugs package. Very powerful, okay? This filter, it's not only about single packages, you could also pass a regex. So imagine that maybe you want, actually, let me check, because I don't want to misinform you. The filter command, it's in here. You can always check the documentation from pm. So filtering, it's either with a single name, or you can also use asterisks, for example. I think that it also accepts a regex, I think. There are multiple ways that you can use a filter. So if you really have a specific, maybe you want to just run all the packages that start with bug. Maybe we could try that. Start bug, and we can do something like this. I don't know if that will work. Let me actually try. I've never tried this. Oh yeah, it worked. Okay, cool. So you have different ways of actually applying the filters to run the packages that you really need to. Maybe some packages that start with a name, maybe some packages that end with a name, maybe some packages that match a specific name, etc. Okay, so just check the filters. You have a lot of controls in here. Okay, cool. So we've talked about recursive. I don't know if we talked about if present, and I think that this is, okay, hold on, let me try something. What if I remove the start command from bug fixes, and then I do pm start from the root? Okay, so I think that this is important also to know. If you do pm recursively start, what's going to happen is it's going to run this start command, but it's just going to run it on those packages that actually have the start command, right? Because I just removed it from bug fixes. No, we no longer have the start package, and then just pm is going to skip it, okay? But I'm going to add it back in here. Cool. Parallel, I think that it just, because if you check, whenever you run pm start, it's not like it runs everything all together. It first runs one, and then it runs another one. So I think that we could do parallel like this, and then it will run everything all together. Yeah, cool. So it's kind of faster. Imagine that you have a bunch of projects and you need to build everything all together. Maybe instead of building one and then the other one and then the other one, you can just pass the parallel flag, and then everything runs at the same time in parallel. Okay. And I think that the rest is actually not that important, not at least for you. I don't want to confuse you with other things. So that's actually it. Because with this, you actually have full control of everything. You can implement a monorepo everywhere. Imagine, for example, the developer starter template. Okay, hold on. You know what? Let's create a monorepo from a developer starter template, because there are a couple of things that we can talk about. So let me go to developer starter, and I will create a new repo from it. Let me zoom in. I don't want Gabriel to be mad at me. And code, let's open with GitHub Desktop. In my case, okay. Actually, no, I don't want to open with GitHub Desktop. I want to use this template to create a new repository like this. Cool. So I'll just say monorepo stream, for example. It's going to be my personal account. It's fine. Okay. It's going to generate the repo. And what I'm going to do is I'm going to take this developer starter repository and I'm going to tweak it to convert it into a monorepo. Okay. So let's now open this with GitHub Desktop. And let me just move this over here, zoom in a little bit. So I'm going to, monorepo stream. I think that will give me an error because I have already the folder. Demo, whatever. Okay, cool. Like that. Okay, so it's cloning everything. And now we can just open with VS Code. So basic developer starter template. Nothing special to see here. Most of you already know how everything that comprises the developer starter template. But now maybe I want to convert this into a monorepo. So instead of having a single package, I want to have multiple packages, and all of them share some logic between them. Okay, and we will see in a second what are the first things that we can share when we turn this into monorepo. So we have the developer starter template in here, and let's just follow again the steps that we did before. So we will have to create a folder called packages, or any other name, it's up to you, but in this case I'm going to use packages. And inside packages, I will create other packages. So let me just cd into packages. Actually, no, let's create the folders. Maybe I want to create a folder called, I don't know, site 1, and another folder called site 2, whatever, okay? So I'm going to init each one of them. So packages, site 1, and I'm going to do pnpm init. And I will do the same for site 2, pnpm init. Cool. Okay, so what we can do now is this source folder that we had in here, we can move it up. We can move it inside each package. So I'm just going to copy and paste it. This might crash. I don't know why, but in VS Code, when you move folders, it usually crashes. I don't know why, at least it happens to me. Cool, so now we have the source folder, which contains some basic code in this index file in each one of the packages. So we can get rid of the source folder from the root package. Everything goes out. Cool. Okay. And what else can we do with it? Now, see how we are getting some errors? This is because TypeScript it's no longer referencing this pathing here. You can see how I'm getting errors. The first thing that we have to do is make sure that we're extending TypeScript in each of the packages, because we are using TypeScript in Developer Starter. So I'm going to create a new file called tsconfig2 .json, and in here I will say I will say extends, and it will extend the tsconfig from the root. Okay, so I'm essentially just saying, hey, grab the tsconfig that it's shared in the root and just extend it. Okay, and this is one of the benefits that I wanted to go to explain before. Cool, because now that we have this, we should no longer be getting errors, or at least, oh yeah, because I have to also say compiler options, and this is going to be the base URL dot text. Cool. So essentially what we're doing is sharing things across packages, and not also sharing blocks of logic like the utils. We can also share, for example, toolings. TypeScript, for example, I have a few rules in here, and this base URL should actually go away. I have a few tools. I have a few settings from TypeScript, and I don't need to be duplicating those settings for each of the packages. I can just share it for each package. So this package can extend from tsconfig from the root. And also the other package can also extend, and it can even override some settings, like new base URL. That's fine. Also, for example, we get shared linting. In the root folder, we have ESLint. In this case, it's using some linting rules that we have to find at Finsweet. And if I try to write some wrong code in here, like using a var like this, you'll see how I'm getting this squiggly line. and which comes from ESLint. And this is because this package is located inside a monorepo package that contains some ESLint rules. So all this tooling, for example, the settings from prettier, also the same, etc. We are also sharing all this, which helps standardizing the repo a lot too, because this means that we have the same TypeScript rules, we have the same ESLint rules, we have the same prettier rules, we have all the same tools that help us, make the code base consistent. And all those tools are shared across all the packages in the monorepo. So very helpful, very powerful, okay? Cool, so the last thing that we'll be missing is, okay, each one of these, I want to build it, okay? So I'm just, for now, copy paste the bin folder. I know that it can be improved, but just for the sake of moving fast, I'm gonna take this, which has the build logic, so the build script, and I'm gonna copy the build command from here, and I'm gonna put it inside of each of these packages. So with this build command in here, it's just essentially going to run the build.js command, okay? Cool, so that's it. I just now need to update the root package to, instead of doing this, I want to run pm recursively build, like this. And now, if I do pm install first, because we have to make sure all the dependencies are installed. Okay, cool. So now what we can do is pm build, like this. And it kind of failed, I don't know why. Package.json exists, but no modules is missing. Oh, hold on, it's missing the pm workspace.yaml file. Remember that this file, it's needed so we can tell pm that we are in a monorepo, like this. Okay, cool. Actually, we need to install again. Sorry. Let's install again. Install, like this. And now it should, hopefully, not work. Why is that? Oh, again, type module. Remember, you just try to always use type module, because it's, nowadays, everything it's ESM, it's ES modules. And it's, I don't know why. Okay. UDLs, yeah, we're having some issues with the paths, the custom paths, but that's fine. I'm just gonna get rid of the paths, because these paths essentially gives us paths aliases. But when in a monorepo, I don't recommend that you use path aliases, because it kind of creates problems in monorepos, because you're addressing different directories. So I just recommend you to not use type aliases and just access directly the files like this. So there's this fixing here, and then I'm gonna fix it again in here, like that. And now if we run pm build again, it should hopefully work now. Yay, okay, cool. So now, just with a single command, it run and it built each one of the projects. So very powerful, we can manage everything. And the last thing that I wanted to mention is, I don't know if you've noticed it, but we are now using ESBuild in each one of these packages, ESBuild from here. And ESBuild, it's actually not installed in here. It's not in the dependencies of site 1. It's not on the dependencies of site 2, but it's in the dependencies of the root package in here. So another benefit of the monorepo is that if you install something at the root of the monorepo, then all the packages get automatically access to that package. So everything that you see here, all the plugins for ESLint, all the settings for TypeScript, all the settings for prettier, the ESBuild package for building the production files. Everything right now, it's in the root of the folder, meaning that we can just access it from anywhere of those packages. Very powerful for organizing. Okay, cool. So we are done. Monorepo is very powerful. If you're looking into building something from scratch, maybe you want to consider using a monorepo, especially if you have different pieces that can just build together for a specific product or a project, whatever. I recommend that you play around with it. Just start coding. And if you like this, please leave a like, leave a comment. And we'll see you on the next Friday. Thank you all. See you. Bye.